Hi guys, and welcome. In this video, we're going to study polar coordinates. Now, what are polar coordinates? Polar coordinates are a new coordinate system that we study where we are dealing with a radius and an angle. So in the polar coordinate system, this is the main axis, which is called the polar axis. It is called the polar axis, which is the main axis. Then the polar axis starts from 0. Now, when you go up, that's inclination angle theta, that's anti-clockwise, right? And when you go clockwise direction, it is negative theta angle. This is clockwise, right? And what is this green line and this red line? Those are the radius. So basically, polar coordinates, in short, is like a cast diagram where you are only dealing with the radius, and like a unit circle, you're only dealing with a thing like this. If you draw diagrams, so if you have a triangle here, right? And this is the theta angle. This is the polar axis, right? And that's the radius. That's what it is. So how do we represent polar axis? Polar point is R and theta. Now you can use degrees or radians here, theta angle. So you must know how to convert from degrees to radians, radians back to degrees. The value of R is here. Now let's draw some polar graphs. So how do I draw a graph of 2 and 5 pi over 4? 5 pi over 4 is basically pi by 4 is 45, 45 times 5, right? So that's 225 degrees, right? So to draw that, there's my polar axis. That's my polar axis. And now to draw this point is, remember, this is 270 line. That's a 180 line, just helping lines. And that's a 90 line, all right? So to draw this point 2, so there's my point here. The radius is 2, and my angle of inclination is right here, which is 5 pi by 4. Or the angle theta is 5 pi by 4. That's how you draw this polar point. Just call it P, Q, R, S. So this is my polar point there, the location. Next one, 3 and 3 pi. So there's my polar axis, right? Now, if I want 3 pi, it's just going to be directly across. What is 3 pi? 3 pi is approximately 180, that's 540 degrees, because 3 times 180. So it's basically the distance from there to there is 3. And 3 pi is, you have to draw this line here. So that is 3 pi. So this is the point Q, the location. Next one, where is 3 and now the angle is negative, right? So if the angle is negative, it means you are going in the clockwise direction. You're not going anti-clockwise. So remember, that's a 90 line, that's a 270 line, that's a 180 line. What is negative 2 pi by 3? Pi by 3 is 60, so that is negative 120. Negative 120 will make you go into the third quadrant, somewhere around there, right? And the radius, so that's the point R, the radius is 3, and the angle is just negative 2 pi by 3. Let's look at the next point, S. Negative to R, now the radius is negative, and this is 3 pi by 4. 3 pi by 4 means 45 degrees times 3. 3 pi by 4 will be 135 degrees, right? So there's my polar axis, right? 135 degrees is somewhere around there. That's 180 line. 135 degrees is somewhere around here, right? So why did I draw broken lines? I'll tell you why. Because I want to locate the point S, right? So you can draw this solid line here, no issues. But now this is 3 pi by 4, okay? And this is 2. What does negative 2 means? Negative 2 means reflect this directly across. So negative 2 will be here. It needs to be a reflection directly across. Right, so this is my point S, okay? Let's make it same length because directly across reflection. So there's my point S. So this is 3 pi by 4 and point S, which is, this represents negative 2. Okay, so these are all the polar coordinates locations. So this is P, that's Q, that's R, that's S. Now let's look at the next one. Where is 5 and 2, 10? So I drew the circles here. Remember, this is radius 1, that's radius 2, that's radius 3, that's radius 4, and that's radius 5. So we want the 0.5 and 210, that is 0. So my polar axis is right there. And I want 210 degrees. Each angle is, see, that's 90. So that's 30, 60, 90, and so on. So because it's 5, it's going to be 1, 2, 3, 4, 5. Right. So there's my angle there, which is 210 degrees, and this is radius 5. That's 210 degrees. Next one, negative 5 pi by 6. So you need to go in the negative angle. 5 pi by 6 is negative 150. It looks like it's going to end up at the same thing because this is negative 90. Negative 90, let's count. Negative 90, this is, okay, this was 180, right? Negative 90, negative 120, negative 150. So that's the point there. Right, so the polar axis is here, and this is the, let's call it point P and point Q. So this is point P and this point Q. It's just that the angle is in the opposite direction, okay? Which is negative 5 pi by 6. Right, that's great. Now remember, you can always switch between angles. You can use degrees or radians. But now in general, you can say the theta angle can always be theta plus 2 pi k, general solution. So every polar coordinate point can be represented by r and theta plus 2 pi k. Because if you go one revolution right around, you're going to come back to the same point. So k is an element of integers. So now let's just substitute. This was 210, all right? And this is negative 5 pi by 6. This is negative 150. If this is negative 150 and that's 210, 210 going in the anti-clockwise direction and going negative, so you can just take 360 minus, right? And because you're going the opposite direction, or you can just say 210 minus 360, right? So theta minus, so basically making the value of k negative 1. So this is a general solution for a polar point. Next. Yeah. Now, how do we go from Cartesian to polar? What does Cartesian means? You are given x and y, right? You're given the point x and y. How do I transform to polar, which is r and theta? Very simple. We have r here. So we were given x and y, right? So how do I find r? R is equal to the square root of x squared plus y squared, right? And how do I find theta with x and y? Very simple. Theta equals tan inverse y over x. That's how you're going to solve, right? Or you can say tan theta equals y over x. That's converting, if you are given x and y, that's how you convert to radius and theta to from Cartesian to polar. Now, how you go from polar back to Cartesian? So if you're given r and theta, and how do I solve x and y? Very simple. We use these formulas here. Uh, remember, we are given r and theta, so we want to solve for x. Forget about y now, because r and theta is given. So x over r is cos theta. So you're going to say cos theta equals x over r. This implies x equals r cos theta. X equals r cos theta. And similarly, forget about x, solve for y, given r and theta. So you're going to say sine theta equals y over r. So similarly, y is equal to r sine theta. Right, so I hope you guys are understanding this. So we can change from polar point r theta to a Cartesian x and y. Now convert the point 2 and pi by 4 from polar to Cartesian. This is already a polar point, so this is r and that's theta. So to Cartesian, we need x and y, right? So what's the value of x? R cos theta, and the value for y is r sine theta. So what is x? R is 2 cos pi by 4, and y is equal to 2 sine pi by 4. Pi by 4 is 45 degrees. So 45 degrees is that right triangle, 1 root 2. Okay, that's 45 degrees. So it's root 2 over 2. and y is equal to 2 sine pi by 4 sine of 45 is also root 2 over 2. So the 2's can cancel out, you get root 2. The 2's can cancel out, y is also root 2. So what's the answer? The Cartesian point is root 2, which is equivalent to the polar point, which is 2 and pi by 4. So quite simple, just using formulas to solve, right? Now, let's convert this point 1 and -1 from Cartesian to polar. Now, it's very important to see where's the location of this point 1 and -1. 1 and -1 is right here. 1 and -1 is in the fourth quadrant. So try to use a negative angle. It'll be easier. You can go and use a positive angle, but yeah, so 1 and -1 is that point. So this is 1 and -1 is down, that's 90, right? So we want to find this angle C. It's already 45 degrees, but because you're going down, it's -45. So what's the radius? R is equal to square root 1 squared plus 1 squared. R is root 2. And the theta angle is, now how did we get R? R is equal to the square root. We want to find R, the distance. It's a Pythagoras. Square root 1 squared plus 1 squared, which is root 2. And what is theta angle? Tan inverse -1. Opposite over adjacent, -1 over 1. So tan inverse -1 over 1 is basically tan 45, right? So, but it's going to be -45 pi by 4. So what's the polar point? The polar point is root 2 and negative pi by 4. Now, if you're going to go positive angle, go right around, then it's like you're just adding 360 or adding 2 pi. So you're going to get root 2 and 7 pi by 4. If you're going to go in the clockwise, anti-clockwise direction, okay? Because this is 45, 360 minus 45 is 315, and 315 is 7 pi by 4. Now, let's look at polar curves. How can I draw this polar curve? R equals 2. R is equal to 2, but there's no restriction on theta. Right, so theta is an element of real numbers. So theta can be any value. What does any value mean? It can be 0, 1, 2, 3, right up to 360. So theta is basically a revolution and R is equal to 2. So it's the equation of a circle. It's basically a circle with a radius 2. There's it here. So R is equal to 2. And there's the center. The radius is 2. 1, 2. Now, sketching the polar curve, theta equals 60 degrees. Now, the theta angle is 60. Oh, yes, we need to describe this, right? R is equal to 2. What is R? X squared plus y squared is equal to R squared. Because remember, what is R? R is equal to the square root of x squared plus y squared. What is R? R is the square root of x squared plus y squared, and which is equals to 2. So if you square both sides, you're going to get x squared plus y squared is equal to 4. So this is a circle with center 0, 0. How we know that? That's x minus 0 squared plus y minus 0 squared is equal to 4. So circle, center, 0, 0 with radius 2. Square root of 4 is 2. So that's what we drew here. Circle, center, 0, 0 and radius 2. Move on to the next one. Theta equals 60 degrees, and we need to describe this line. Theta equals 60 degrees means we need to draw a 60-degree line from the polar axis. And remember, this is a 60-degree line. Let's make this line straight. Now, remember, theta is 60 degrees, but what's the radius? So radius, there's no restriction. Radius is an element of real numbers. Radius can be anything. So this is 60 degrees. So theta equals 60 degrees describes a line. A line, we need to describe it. A line with an inclination a line with an inclination angle of 60 degrees. Nice. Move on to the next question. We're looking at polar curves, right? Find a Cartesian coordinate, find a Cartesian equation for the curve r equals 2 cos theta. Now, what was cos theta? Remember, r was equal to, x was equal to r cos theta, right? We know that from Cartesian to polar, polar to Cartesian, r cos theta. So what is cos theta? Cos theta is equal to x over r. If you remember the diagram, that's xy, that's r, and that's theta. What is cos theta? Cos of theta is adjacent over hypotenuse. So adjacent is x over r. So r is equal to 2 times x over r. Now you're going to multiply by r both sides. So you're going to get r squared is equal to 2x. What is r squared? R squared is x squared plus y squared from this diagram. So you're getting x squared plus y squared is equal to 2x. Now what is this? Describe it. This is an equation of a circle. How? You need to bring the 2x over. If you bring the 2x over, you will get x squared minus 2x plus something squared, because you need to complete the square here, minus something squared. No. Because you brought the 2x over, we're going to add the y squared here, is equal to 0. Now, because you are adding something here on this side, you're going to add the same thing onto the other side. So I changed nothing here. I just brought the 2x over, I got minus 2x. I still have the same equation, x squared minus 2x plus y squared is equal to 0. I'm just adding something. What is the something that you add? You take the coefficient of x and you divide it by 2. So you're adding -1 and you are adding -1. You always have to take the coefficient of x and divide by 2. So this becomes a perfect square. That's basically x minus, what's the value of this? 1 squared plus y squared is equal to 1. So what is this? This is circle center, circle center 1, 0 with radius is equal to square root of 1, which is 1. Next one. If we want to find the distance between two polar points, if you want to find the distance between polar point 1 and polar point 2, let me just draw a brief diagram to explain this. So I have, let's take something like this. One and 2. So let me take a polar point P1 here and P2 there, right? So I'm going to draw this diagram. Now remember, remember P1 is coming with θ1, right? And P2 is θ2, which is this entire angle there, which is θ2. So what is the distance between these two polar points here? What is the distance from the origin to P1? The distance from the origin to P1 is R1, and the distance from the origin to P2 is R2. And what is the angle between R1, R2? Look at this triangle here, OP1, P2. This angle over here is basically θ2 minus θ1. So it doesn't matter whether you use θ1 minus θ2 or θ2 minus θ1. All right, so in this case, it's fine. So θ2 minus θ1, it's just like using the cosine rule now. So how do we find the distance between two polar points, P1, P2? The distance between two polar points, P1, P2 is equal to, you can just use the cosine rule, right? So which is square root of R1 squared plus R2 squared minus 2R1 R2 cos of the angle. What is the angle? θ2 minus θ1. Now, let's solve this equation using P, which is 360 and 4 and 150. So we're finding the distance between the polar points PQ. So PQ is equal to square root of, what's R1 squared? 3 squared, plus R2 squared is 4 squared, minus 2 times 3 times 4, cos of theta 1 minus theta 2, or theta 2 minus theta 1, doesn't matter. So 150 minus 60. Now, square root of 3 squared plus 4 squared, right? So that's 25 minus 2 times 3 times 4 is 24. And what is cos of 90? What's cos of 90? Remember the cos graph? Starts from there, comes down, and there. Cos of 90 is 0. That's the important point in the cos graph. So minus 0. So not minus 0, times 0. So 24 times 0. So you just got square root of 25, which is 5. So the distance between these two polar points, PQ, is equal to 5. Simple. Now let's have a look at some practice questions. Find a different pair of polar coordinates that names the same point P, which is 2 and 240. So we're going to draw this point here, 2 and 240. Remember, 240 is closer to 270 line. All right, so there's your line. This is your polar axis. 240 is somewhere around here. And that's the angle, right? So this is 2 and 240. Now, you can also go in the negative angle. So it can be negative 120. So where's negative 120? 2 and negative 120. Yeah, that's perfect. Next, avoid using negative radius. Find a different pair of polar coordinates that names the point. So this is 2 pi over 3. That is pi over 3, 60 times 2, 120. This is 120 degrees. So it's a point here, 120 degrees. And the point is 3. So if you're going right around, it's going to be negative 240. Because 240 plus 120. So because you're going in the clockwise direction, it's going to be negative 240. And what is negative 240? Negative 240 will be, so you're taking 2 pi over 3 minus 2 pi. It's like subtracting 360 degrees. So 2 pi over 3 minus 6 pi over 3. Why? Because that's over 1. You need to multiply by 3 over 3. So that's negative 4 pi over 3. So where's negative 4 pi over 3? 3 and negative 4 pi over 3. That's correct. Next one. A circle in the polar coordinate system is centered at the origin and passes through the point 4 and 0. So circle is centered at the origin. So that's basics, right? And it passes through the point 4, 0. So circle center is 0, right? And it passes through the point 4, 0. That's 4 and 0 degrees. It passes through this point 4. Right, and 0 degrees. So it passes through the point 4. Now, why did they put a degrees there? Because on the x-axis, there is no inclination. That's why it just passes through 4. So that's a radius. This is r, right? Find the polar equation. Very simple. This is circle equation with the radius 4. So r is equal to 4. That's it. Next one. What is the diameter of the circle represented by the polar equation r equals 4? Diameter is twice the radius. This is the easiest question, d is equal to 8. Next one. The graph of theta equals 45. If you're drawing theta equals 45, that's the polar axis, and 45 degrees is right here. No restriction on r. It's a line, right? That's 45 degrees. So it's a line. Find the distance between polar point P1, P2 in the polar plane. Simple. Distance is equal to square root of 3 squared plus 6 squared minus 2 times 3 times 6. Use the distance formula, right? Cos 30 minus 90 or 90 minus 30. So you can do both, 90 minus 30. I proved it to you. And so the square root of 3 squared is 9. 9 plus 36 is 45. Minus 224. And cos of 60 is half. Okay? Because 90 minus 30. Now, solving this equation, You got square root 45 minus 12. Square root of 45 minus 12, which is the square root of, that is the square root of 33, unless we made a mistake here. Square root of 33. Wait a second. Square root mod 6 squared is 36, 9, 2 times 3 is 6. Oh, okay. That's where the problem is. That's why we have multiple choices, right? So you can make sense of it. So what we have is 6 times 6 is 36. So minus 18, not minus 12. Minus 18. So 45 minus 18, 45 square root. That's 27. Square root of 27. Yeah. And the square root of 27 is square root of 9 times 3. Square root of 9 is 3. 3 root 3. So that's the answer. Moving on to the next question. Let the distance between polar point P1 and P2 be 10. Find R. So the distance between these two polar points is, so you can kind of like draw it here because you don't have to use the distance formula, right? Because sometimes it's just obvious. Let's try to locate these points because we got 0 and 90. 0 is on the x-axis, on this polar axis, and the radius is r, right? R and 0 is here, and P2 is 8 and 90. So it's on 90 degrees, P2. That's P2, and this is P1, and that's R, right? So there's your 90 here. So what's the distance between P1 and P2? The distance between these two polar points. Come on, guys. That's easier, right? Because this is 10 and this is 8. So it's your 6, 8, 10 triangle. If you're solving for R, you can just solve square root 10 squared minus 8 squared. You can use Pythagorean triples and you get 6. Moving on to the next question, or you can use the distance formula, right? Find the polar coordinates of the point with the rectangular coordinates. So what's the polar point given x? So what's the equations? R equals the square root of x squared plus y squared. In this case, it's going to be the square root of, what is x squared? You're squaring the root 3, so this is 3. Squaring the 1 is 1. So 3 plus 1, the radius we already got, which is 2. Square root of 4 is 2. And then theta equals tan inverse negative 1 over negative root 3. Negative 1 over negative root 3, which is tan inverse 1 over root 3. 1 over root 3 is your 30, 60, 90 triangle. That's 30 degrees, 1, 2, and that's root 3, right? Special angles. So when will I get 1 over root 3? Opposite over adjacent. Opposite is 1, root 3 is adjacent. So tan 30. So this is just 30 degrees. So 2 and 30 degrees should be your answer. There's it here, D. Next one. Find the rectangular coordinates for the polar points. So rectangular coordinate x equals r cos theta. R is negative 4. Cos theta is cos 240. And y is equal to negative 4 sine theta, sine 240, right? Negative 4. Sine is in the third quadrant. That becomes 180 plus 60. So that's negative sine 60. And that becomes negative 4 times negative cos 60. That's also negative because it's in the third quadrant. So this answer here is negative 4. Cos of 60 is negative half. Cos of 60 is half. So negative, negative. That's going to give me 2. So x is 2. Sine 60 is root 3 over 2, right? So that's going to give me 2 root 3. So what's the answer? X equals 2, y equals 2 root 3. 2 and 2 root 3. Perfect. Next one. Find the rectangular coordinates for this point. Again, same story. X is equal to 6 cos pi by 3 is 60 degrees. So 6 times half. And y equals 6 sine 60 degrees. So that is 6 sine of 60 is root 3 over 2. So 3 root 3 here for y and 3. 3 for x, 6 times half is 3, or half of 6 is 3, 3 and 3 root 3. Next one. Write down the rectangular equation for this. What's the rectangular? Write the rectangular equation x squared plus y squared in polar form. So what is x squared plus y squared? That's r squared. 4. What is y? Y is equal to r sine theta. So we're going to write r sine theta. Now we're going to divide both sides by r. So you're going to get r is equal to 4 sine theta. That's it. Just division by r on both sides. Divide by r. So r equals 4 sine theta. First one. Next question. Write the equation y squared minus x squared plus 1 in polar form. So this is a bit difficult. Look at the forms. So we're going to say y squared minus x squared. What is y? Y is equal to r cos theta, r sine theta. Y is equal to r sine theta squared minus x squared is r cos theta squared is equal to, negative 1 is equal to 0. Now simplify. This is r squared sine squared theta minus r squared cos squared theta is equal to, take the 1 over, right? Now take out r squared as a common factor. We can see sine squared minus cos squared. That's not an identity. But cos squared minus sine squared, that's a double angle. So take out negative r squared, right? So we get, take out negative r squared from here. We're getting cos squared theta. And take this and divide by negative r squared. You get negative sine squared theta is equal to 1. So now we see that this part over here is a double angle. Cos double angle. This is just cos 2 theta, and that's r squared times cos 2 theta, which is equal to, let me multiply both sides by negative, so that's negative 1. I'm still stuck with a negative. Negative 1. Why did we get a negative 1? Oh, this is a plus 1. All right, so that should be a negative 1 on the other side. So there should be a negative 1 on this side. Okay, so if you multiply both sides by negative, then it becomes 1. So r squared is equal to 1 over cos 2 theta. 1 over cos 2 theta is a reciprocal, so that is sec 2 theta. So this implies r is now equal to square root of sec 2 theta. It's supposed to be plus minus, but they don't have a plus, they don't have a minus, so just r equals sec 2 theta. That's our answer. Next one. Write the rectangular equation. Write the rectangular equation y equals negative 3 in polar form. What is y? What is y? Y is r sine theta is equal to negative 3. Solve for r. Negative 3 over sine theta. This is much easier than the previous one. 1 over sine theta is cosec theta. So negative 3 CSC theta. Negative 3 CSC theta. That's the one. All right. So I hope you guys understood everything. All the best, guys.